.9 operations with complex numbers. This is based off what we did in section 2.5 with learning about complex numbers. We're going to start off the lesson talking about a complex plane. Complex plane is very similar to an XY axis. The horizontal axis we're going to use for the real numbers. The vertical axis we're going to use for the imaginary numbers. So it's going to look like this. The y's are going to be your imaginaries. The x's are going to be your reals. Remember, it's in the form of a plus bi. Just make a 5 by 5. Imaginaries are your y's, reals are your x's. And what we're going to do is we're going to plot these 4 points. For a, 2 minus 3i. Which part's your real piece? 2. Which one's the imaginary? Negative 3i. So we're going to go on the reals to 2. Imaginary is negative 3i, so we go down 3. That's point A. For point B, which direction do I go? Left, how many? 1, then what? Up 4. That's point B. For point C, how do I do it? Right 4, up 1. Why 1? This is really 1i. Now for D, there's no real part, so I'm staying at 0. And I go down 1. That's part D. How about the first one? Go to the right 3. How about the second one? Go up 2. How about the next one? Left 2, down 1. And the last one. Right 3, up 2. That's your last point. Now, whenever I'm talking about these points, I can always find the distance to 0. When we're talking about any number, either be on this graph or in a number line, we can find the distance to 0. What do we call distance to 0 in math? Absolute value. So the distance to 0 is the absolute value. So if I take the absolute value of 2i, what's the distance to 0? 2. It takes me 2 to get back to here. For this one, the absolute value of 3 plus 0i, what's the distance to get back? 3. But when we talk about something like D, the absolute value of 3 plus 2i, a lot of you are just in the habit of just saying, oh, it's 3 plus 2i, it's whatever it is positive. But it's the distance to 0. It's the distance from D to 0. Is it easy to tell exactly how far that is? No. Because it's slanted, it cuts through the squares. But I could do this and make a right triangle. What's this distance? 2. And this distance is 3. What can I use to find this one? Pythagorean theorem. Pythagorean theorems, a squared plus b squared equals c squared from geometry. My a and b are my legs. So I have 3 squared plus 2 squared equals c squared. What's 3 squared? 9. 2 squared. Put them together, I get 13. Take the square root to get rid of the square. Square root of 13 is what c is. This side here is the square root of 13. Well, the square root of 13 is, let's see, it's in between 3 and 4. Because 3 squared is 9, 4 squared is 16. So it's 3 point something. Hypotenuse is always the longest side. That one's 2, that one's 3, so it has to be larger than 3. 3 point something, I know I'm good. So what we just said is when you're taking the absolute value of a complex number, you're taking the square root of a squared plus b squared. Your legs are the numbers that are attached to your real number and your imaginary number. So 3 squared, 9, 4 squared, 16, 9 and 16 is 25. Take the square root of that, I get 5. Finding the absolute value of 3 plus 5i. How do I set it up? Square root of 3 squared plus 5 squared. 3 squared, 5 squared, put them together, you get square root of 34. The only mistake I saw coming around, a few of you lost the square root. You need square root of 34. You don't need to actually type this in. Just leave it as square root of 34. Now, part B, you have square root of, 13 squared plus, what's the imaginary part? 0, which really just means 13 squared is 169. Your square root is, not square root of 13. Why is it 13? Why is this equal to this? If I look on the graph, whenever the points are on one of the axes, it is just going to be that number. And it's going to be that number positively because you can't have negative distance. So if I'm negative 7i, it's down here somewhere, right? What's the distance back to 0? 7. So if you only have one number, you just take the absolute value. Now for the a, when you have a complex number of a and I, a and b, you have to do the a squared plus b squared. When we're going to add or subtract complex numbers, these look a lot more complex than they need to be. When we talked about solving the complex numbers in section 2.5, when we had to find the x and the y that made the things true, we made sure that we kept the reals with the reals, the imaginaries with the imaginaries. So when you're adding or subtracting, this is a real plus that's a real. Keep the reals with the reals. Put the imaginaries with the imaginaries. So 2i plus a negative 7i. Now you don't need to write this out. I'm just showing you so you can understand you're breaking the two pieces. The reals. What's 4 plus negative 6? Negative 2. What's 2i plus negative 7i? Negative 5i. And that's your answer. All right, I have 5 minus 2i minus negative 2 minus 3i. Coming around, I saw a couple people do this little trick. You distributed. If I distribute to both, it makes this a positive, which if I distribute makes this negative. Positive makes this negative. Positive. So what a few people did is 5 plus 2. What's 5 plus 2? 7. What's negative 2i plus 3i? 1i, so I just write I, and that's your answer. If you were to break it apart, it's 5 minus negative 2 plus negative 2i minus negative 3i. This negative has to go to both. Most of your mistakes are going to come from forgetting to distribute to the second number. Just to show you 5 plus, or negative is positive, you get a 7 here. Negative here makes that a positive. Negative 2i plus 3i, you still get 1. That was adding and subtracting. Now with multiplying, I have negative 2i times negative 4i. What do you think I should do? Distribute. What's negative 2i times 2? Negative 4i. What's negative 2i times negative 4i? Plus 8i squared. I times I is I squared. Remember back from a few sections ago, what does I squared really mean? What does I squared really mean? I squared means, what does I even stand for? Imaginary, but when do you get imaginary numbers? When you take the square root of a negative number. So when you take the square root of a negative 1, that's when you get an I, correct? So if I square an I, so if I square a square root, what are you left with? Mr. Lakovich, thank you for... The square and the square root cancel each other out. You're just left with negative 1. I squared means negative 1. So whenever you see that I squared, it means negative 1. What's 8 times negative 1? So this really says negative 8 minus 4i. That's your answer. I put the negative 8 out front because it's a real number. It goes real, then imaginary. Now, I'm multiplying, and I have 3 plus 6i times 4 minus I. What do you need to do? Can't put the reals and imaginaries together because we're multiplying. What's that called? FOIL. You need to FOIL or distribute. So you're taking 3 times 4 is 12. 3 times negative I. Negative 3i. What 6 times, or 6i times 4? Plus 24i. What 6i times negative I? Negative 6i squared. Now, I know that I squared means what? Negative 1. So what does this really make this right here? Positive 6. Now I'm going to combine my like terms. When I look at my reals, what's 12 and 6? 18. When I look at my imaginaries, what's negative 3 and a positive 24? Plus 21i. That is your answer. All right, when we look at 2 plus 9i and 2 minus 9i, coming around, I was also seeing if any of you noticed something. They're the same, but the signs are different, which, remembering from way, way back, when the signs are different, but they're identical, that's special. I take the first term and square it. What's 2 squared? 4 minus, what's 9i squared? 81i squared. But what does I squared mean? Negative 1, so it makes this plus 81. 4 and 81 is 85. That's because you knew a shortcut. If you didn't know the shortcut, you would have went and distributed. 2 times 2, you get 4. 2 times negative 9i, negative 18i. What's 9i times 2i, or just 2? Plus 18i. And then 9 times negative 9i, negative 81i squared. But what happens here? They cancel each other out. You did this. You might have had one extra line of work. It's not wrong if you did that extra line. A few of you left it like this. You need to remember that I squared means negative 1. And when there's no i's, you don't need to put 0i. We can just leave it as is. Now, another little thing about i's, whenever we take i's and change them exponentially, I to the first just means I. If I square an I get negative 1. Well, if I cube an I, well, that's the same thing as I squared times by I. Well, I squared means negative 1. I means I, so it's negative I. I to the fourth really means I squared times I squared. Since I squared is negative 1, negative 1 times negative 1 is 1. If you tried 5, I to the fifth, you can break it down to I to the fourth times I. I to the fourth we know is 1. 1 times I is I. We can take this and use any power. Everything is built off from the 1, 2, 3, 4. I can break every number into one of these numbers.